Hello, my friends. We're going to find the limits for various expressions. These examples come up all the time on your exams, and if you want more, I got other sweet videos of limits in calculus, so you can check those out. But for now, we'll jump right into it. So for our first example, it's the limit as x goes to 4 of this polynomial, 2x squared minus 4x plus 8, and there's no problems at x equals 4, right? This is a polynomial, so it's continuous. And if you plug in x equals 4, nothing's undefined. So you can literally just plug it in here. So we would get 2 times 4 squared minus 4 times 4 plus 8. And 4 squared is 16 times 2 is 32 minus 16 plus 8. And 32 minus 16, 16 plus 8, I believe, is 24. So that's our limit there. All right, so the next example here, x times e to the x ln x. And don't panic, we can just kind of break it down. As x goes to 1, we can plug in 1 here for x. There's no problems there. There's no problems with e to the x. This is e to the x by itself is continuous. But ln x is undefined. Oh, sorry, it's not undefined. What am I saying? It's 0. So if you plug in 1, it's 0. So as x goes to 1, this factor is constant, becomes constant. This factor becomes constant as well. But here, this goes to 0. So since this one's going to 0 and these are all going to their own constants, then the limit of this function together is 0 as well. Let me know if that made sense. Let me know if you like that in the comments or not. Anyways, I'm going to move on. Okay, so this is a super common example that comes up. And here we have a problem. Because if you plug in x equals 2, because one of the limit is x goes to 2. If you plug in x equals 2 here, we have 0 in the denominator, so it'd be undefined. So that's the problem. That's not the answer, but that's our problem we need to overcome. And pretty much all the time when you can't just plug it in directly, you just need to simplify it first. So we have this quadratic expression in here, and I have a whole video on how to calculate quadratic, or not calculate, how to factor quadratic expressions. So I'm just going to jump to the answer here. It'd be x minus 2 times x plus 1. I know this is the answer because these two numbers have to multiply to negative 2, but add to negative 1. If you do enough of these, it just becomes pretty mundane over x minus 2. Now look at this. We have x minus 2 divided by x minus 2. So this cancels out. Oh, see what I did wrong? You might lose half a mark if you don't include the limit as x goes to 2. So your prof likes to see that. The limit as x goes to 2 of x plus 1. And this has no problem. We can plug in x equals 2 here. So that's just 3. Now, the function doesn't exist at x equals 2. There's a hole. So it's kind of like this. So as x, the function behaves like x plus 1. So this is just a straight line with a y-intercept of 1, slope of 1, going up like this. Where at x equals 2, this is x. This is the function here. There's a hole, it doesn't exist, but as we approach from the left, it approaches 2. Oh, sorry, it approaches 3. And as we approach from the right, it approaches 3 as well, but it doesn't actually exist at that function. Now for this next one here, we have something somewhat similar, but with absolute value signs, super common on exams. The function is x squared minus a squared divided by the absolute value of x minus a. And we want to know the limit as x approaches a from the left, the right, and the overall limit here. Well, let's break this up again here. This is a difference of squares, so we can factor this. X plus a times x minus a. And this is all divided by, oh, yeah, that's fine. I said I didn't include my limit, but I don't have to include a limit here as x minus a. Okay, now we need to put on our thinking caps here. So we can't just cancel this directly because there's an absolute value sign. As x approaches a from the left, x is less than a. If we have a function, and here's a, and this is x approaches a. So from the left, that means x is over here. X is like over here, approaching a. So x is less than a. X is less than a. I'll write it here. X is less than a. If x is less than a, then this has to be negative, right? X is less than a, so x minus a has to be a negative value. Here, this is negative as well, but if you take the absolute value of it, it's positive. So this is always positive. So x minus a cancels out with x minus a. The number is the same, but this one is negative, and this one's positive. So this is the same as x plus a times negative 1, because these cancel, although this is negative and this is positive, leaving it negative. Let me know again if this made sense as well. So this would be, yeah, negative. So this is, now there's no problems here. So if we plug in x equals a, it's not undefined anymore, so we can plug that in. So we get a plus a times negative 1. So that would be negative 2a. Negative 2a here. Okay, so as x approaches a from the positive side, x is now greater than a. So I'm just going to change this here to a greater than a. So x is greater than a. That means x is larger than a. So if x is larger than a, this is always positive. This is always positive. So when these cancel, we have a positive over a positive. So we're left with x plus a times positive 1, because these both canceled. And rather than being negative 2a, we have positive 2a. Positive 2a. Okay, and now the overall limit as x goes to a doesn't exist, because the limit from the left-hand side is different from the limit from the positive side. So one's negative, two, these aren't the same numbers. One's negative, one's positive, so does not exist. Sweet. Awesome, possum. Okay, another common one, we have a fraction inside a fraction. And first thing we do, I do anyways, I want to see if, can I just plug in x? This seems continuous. If I plug in x, x is 2, 2, we get 2 over 2, which is 1, 1 minus 1, it's 0, we have a problem. It's not continuous at x equals 0. So we need to get rid of this problem in order to plug it in. So to do that, we usually want to get rid of these fractions here. And whenever you see a fraction inside a fraction, I always think common denominator. So we'll find the common denominator for both and simplify it. Up here, we have a denominator of 3, so we'll multiply the top and bottom by 3 of this term. This one will multiply the top and bottom by x to get the common denominator of x. Now here we have everything's over 3, and we have x squared minus 1 times 3, which is just 3. And here the common denominator is x, and we have 2 minus 1 times x, so 2 minus x. All right, so to simplify this, some people call it kind of just kiss and flip, where you can take this and flip it around. I'm going to do this without taking any kind of steps or shortcuts, things like that. I want to get rid of this 3. And if this is the whole numerator, right, and this is the whole denominator, I'm going to multiply this numerator by 3 and the denominator by 3, 3 over 3. And in that way, these 3's cancel, because this is like 3 over 1. It's like 3 over 1 in the numerator over 3 over 1 in the denominator. So that cancels with this 3. This 3 doesn't cancel, of course. Now we want to get rid of this x, so we'll multiply, whoops, not 3, but x, the top and bottom by x over x, so that this x cancels with this x here. And we're left with a numerator of x squared minus 3 times x divided by 2 minus x times 3 times 3. Okay, now if we'll clean this up a little bit, the limit as x goes to 2 of, I'll just say x times x squared minus 3 over 3 times 2 minus x, just kind of clean it up a bit. Notice we don't have anything that cancels here, and we still have a problem if we plug in 2 for x. We're still undefined. So we want to look at the behavior as x goes to 2 from the left and from the right. So here's our graph here. Here's x. Here's our function. Now, as we approach 2 from the left-hand side, say from the negative side, x is less than 2. So we're approaching it. If x is less than 2, this is positive, right? This is positive. So this is going to 0 from the positive value. And if this is going to 0, that means this whole function is going to infinity. And since this is positive, this whole function is going to go to positive infinity. So the limit as x goes to 2 from the negative side is positive infinity. But the limit as x goes to, and yeah, so this is 2, this is positive. This will be positive as well because 2 squared is 4. 4 minus 3 is a positive number. But as x goes to 2 from the positive side, x is greater than 2. See, x is greater than 2 because we're approaching 2 from the positive, so we're greater than 2. If x is greater than 2, this is negative. So this becomes 0, but it's negative as it's approaching 0. So it's a negative approaching 0. So this whole thing is going to infinity, but it'll be negative. So it'll be negative infinity here. Since the limit from the left-hand side does not equal the limit from the right-hand side, this limit here doesn't exist. So the limit as x goes to 2 of our function, it does not exist, d and e. And we'd have to define this as our function here. Okay, well, that's it, everyone. Thanks so much. Check out my other videos on limits and calculus and math, physics, and chemistry. And that's it. Cheers. See you in the next video. Thanks for watching, everyone.